Hello my dear students, I welcome you to NEET World. So today we will be discussing about previous year questions of NEET 2022. So in the last sessions we discussed 2019, 2020 and 21 question papers, right? So today we will be discussing 2022 NEET chemistry part. Okay, so I hope you already seen last sessions also. I hope you are continuously watching our channel for more informative and more preparative videos, right? I hope these videos are highly helpful for your preparation, right? So if you really like our content, please click on the like button first before you are starting your video. Okay, so just try this question once give a try from your side. How can we solve this kind of questions? See, the pH of solution containing 50 ml of 0.1 molar sodium acetate and 0. We will be taking, yes, these are fine. So they have given this data and the given data is like that. So how can we find the pH of this particular mixture? Okay, pH of this solution. See, the solution is made up of acetic acid. See, it is acid plus salt of that acid, right? So this is a mixture they have taken. So this will be forming, see what is the quantity they have taken for acid. So 50 ml they have taken, 50 ml into 0.1 molar. So this will be 5 millimoles. So how many millimoles of acid is there? 5 millimoles of acid is there. So what about its salt? So see, 50 ml of each. So for this also the salt quantity is how much? 0.01 into 50 ml. So it means this will be 0.1 it means 0.5 millimole salt is there. So this is a combination of acid and its salt. So we can say this kind of combinations as buffer solutions. What I am saying? Buffer solution. Since it is made up of weak acid plus salt of weak acid with a strong base, this is called as acidic buffer. Okay, so what is the combination? Yes, so this is also important. How can we identify a buffer solution? In order to form a buffer solution, so you should take in this combination. For example, if you want to prepare acidic buffer, so you have to take weak acid plus salt formed from weak acid plus strong base. For example, weak acid, here I am taking acetic acid. Okay, acetic acid is a weak acid. So salt of weak acid plus strong base has to be considered. So for this, though this is a weak acid, same thing I am writing here, CH3COOH plus strong base, you give one example, NaOH I am taking. So if we take like this, we will be getting a resultant solution as a buffer solution. So in order to prepare this acidic buffer, we have to take weak acid in the larger quantities and strong base in the lesser quantities. Therefore the resultant solution will be having more amount of weak acid and some amount of this salt formed from weak acid plus strong base. Therefore the resultant solution is called acidic buffer. So whenever we have an acidic buffer, the pH formula should be used here. The pH equals to pKa plus log concentration of salt by concentration of acid. If it is acidic buffer, take acid. If it is basic buffer, take it as base. Okay, so this is for acidic buffer. Okay, so acetic acid is there, this is acidic buffer, you can say. So now pH equals to, what is the pKa value they mentioned? That is pKa value of acid is 4.7457 plus log concentration of salt we required now. So now concentration of salt, if they give, see here it is given 50 ml of 0.1 molar. So here, so we can take this one. So number of moles of N salt by N number of moles of salt by number of moles of acid also you should take here. Okay, so now from this, what is the final answer we are getting? So here 4.57 plus log, what is the number of moles of salt they given? Salt they given as 0.5, right? Salt is given as 0.1 molar. Sorry, the salt is given as, see here salt how much they given? See here 50 ml of 0.1 molar acetate sodium acetate is given. So 50 into 0.1. Okay, this is a concentration of number of moles of salt, and same 50 ml of 0.01 molar acetic acid is given. So take it like this. So 50 removed, so this will be 10 times, this will be 10 times. Okay, so if it is log 10, then it will be 1. Therefore, what is the final answer here we are getting? So here 4.57 plus 1, so this will be 5.57. so this is how you need to calculate pH of a buffer. Okay, pH of an acidic buffer. So here we have option number 2, which is 5.57. so that is what the answer we got. Okay, so what I told you, acid is given how much? 0.01. so here acid is given 0.01. okay, how much volume it is mentioned? 50 ml they mentioned. Okay, that will be 0.5 millimoles of acid. Again here what is the salt given? Salt given as how much? 50 ml of each, salt plus 50 ml salt, 50 ml of acetic acid is given. So 50 ml of each, it means 50 ml salt with concentration 0.1. so what is the resultant here we will be getting? 5 millimole salt. So that is what I have written. So if you simplify this, 5 by 0.5 we will be getting. So that is nothing but 10. Log 10 is 1. 4.57 plus 1, that will be 5.57. so this will be the answer. Okay, I hope it is clear. Always take weak acid more than the strong base, therefore the resultant solution formed will be acting as a acidic buffer. Okay, so in order to prepare basic buffer, see I am adding few more points in order to get more clarity. In order to prepare basic buffer, prepare basic buffer I am saying. So what is the combination we can take? We have to take weak base plus salt formed from this weak base plus strong acid. Okay, so in order to prepare this, so let us take one example. I am taking NH4OH, this is a weak base. I am treating this with a strong acid like HCl. Okay, so in order to make this solution, in order to make buffer solution, basic buffer, if I take this as 2 moles and this should be less than this 2 moles, so let us take this as 1 mole. Okay, then what is the resultant solution? We will be having NH4Cl, we will be having NH4Cl and then next H2O. So out of these 2 moles, only 1 mole of HCl is reacting with 1 mole of sodium hydroxide. So 1 mole is reacted, 1 mole is remains unreacted. So 1 mole, this 1 mole, this 1 mole is reacted, this another 1 mole is remains unreacted. So the resultant solution will be having 1 mole of NH4Cl, NH4OH and 1 mole of NH4Cl. So this kind of combination, see, weak acid plus salt formed from weak base plus salt formed from weak base plus strong acid. Okay, whenever we have this kind of combination, we should say this as basic buffer. Okay, we should call it as basic buffer. Okay, I hope it is clear. So for basic buffer, POH should be calculated. So POH is equals to pKb. See, for acidic buffer, pH equals to pKa plus log salt concentration by acid concentration. For basic buffer, we should calculate POH. POH equals to pKb plus log concentration of salt by base. Concentration of salt by concentration of base. Yes, this is what you need to understand here. Okay, it's about like buffer solutions. Okay, now what is the relation between pH and POH? pH plus POH equals to 14. So this will be applicable at 25 degrees Celsius. So you can convert now pH into POH or POH into pH using this relation. I hope it is clear, right? Then next, so whenever you are solving some questions, so what you need to do is you need to like just try to cover the relating parts. I mean, see, if you are studying about, see, I have there is a question on acidic buffer. I also covered about basic buffer and what are the formulas we have in that question. So what are the applications we can do, that's how you need to cover your revision part now. Okay, because we have very less time but we need to revise effectively. So this is one of the method to revise effectively. Okay, now here Dalton's law they are asking. So which one of the following is not actually states of matter, here this question is from. Okay, which one of the following is which one is not the correct mathematical equation for Dalton's law of partial pressure. Okay, so first equation is given as Pi equals to correct relation they are asking, na? So this is not the correct one. Partial pressure of a gas, let us say ith gas equals to total pressure multiplied with the mole fraction of that gas. Okay, so which means where do we have any equation like this? Pi equals to pressure of the ith gas, no, what about this? P gas equals to partial pressures. So sum of the partial pressure P total equals to sum of the partial pressure. See, for example, I have a mixture of gases. Okay, let us say the mixture gas 1, gas 2, gas 3 are there. So gas 1 will be having partial pressure P1, for 2 it will be P2, for 3 it will be P3. So P total now equals to P1 plus P2 plus P3. This is also comes from Dalton's law, and we have one more equation also. That is one thing, and so second one is correct only, and third one let us look here. P equals to P of gas. See, fourth one is whatever I have written here, that is what the fourth option here it is mentioned. Okay, look here once. So what they are saying, P of a gas I equals to partial pressure of ith gas, total pressure of gas, total pressure exerted by all gases multiplied by its mole fraction of that ith gas. Okay, so this is how, for example, P of partial pressure of gas 1 equals to mole fraction of gas 1 into P total. So this is how we need to write. Okay, so fourth option also correct, and they are saying not correct one. So third one is correct, second one is correct, and fourth one can be also written as third, like option 3, because mole fraction is what? So P total is what? So PV equals to nRT na, RT by V also we can write na. So that is what they did here. Okay, I hope it is clear. So this is also clear. So 3 options are correct, 2, 3, 4 are correct, but the incorrect one is here is first option. So you have to choose first option. Okay, so they are asking not correct, so first one is not correct. So can you give a try for this question? Incorrect statement regarding the enzymes is, so which one is incorrect here? Enzymes are specific, very specific, and for a particular reaction and for a particular substrate there will be a particular enzyme and for their activity. So enzymes are what? These are biocatalyst. Okay, so they will like chemical catalyst, enzymes reduce the activation energy. Yes, so how the catalyst is used in normal chemical reactions, here the same function is done by the enzymes in the biological activities. Okay, so this is also correct. So enzymes are what they are saying, polysaccharides. No, these are not polysaccharides. So these are protein molecules we can say. Okay, so they can be protein molecules but not polysaccharides. Okay, so fourth option is incorrect, again incorrect, so fourth one is incorrect. Okay, for this question, so will you try, I will only explain. See, photoelectric effect. What about photoelectric effect? This photoelectric effect you will be studying in physics, also in chemistry, structure of atom. So the suitable element for photoelectric effect is alkali metals. Out of that, the element with lower ionization energy will be very suitable. So from the given species, cesium will be having lower ionization energy, therefore it is used in the photoelectric effects. So D4, only this option D4 is only here. So directly you can choose first answer. So first option, if you want you can recheck here. Okay, and A2. So A2 means electrochemical series, electrochemical cells. Okay, next B3. Yes, sodium is used as coolant in fast breeder reactors. Yes, nuclear reactor. See, we are studying about reactors now. There will be having. Yeah, KOH is used for used as absorbent for carbon dioxide. So C1. So C1, so option 1 will be most correct answer for this question. Okay, so now can you try this question? Write primary amines are NH2 with HNO2. So what kind of product is formed here? HNO2. So just give a try for this question. So take 1 minute of time to solve this question and give me the answer for that. Yes. So how can we solve this question again? So primary, whenever these are amines are reacting with HNO2, it will form diazonium salt, like it will become like this. Okay, here with positive charge. Okay, so this is what diazonium salts are formed. Yes, to give unstable diazonium salt. Okay, next, primary aromatic amines react with HNO3 to form diazonium salt, which are stable even above 300. No, these are not stable above 300, therefore it will undergoes dissociation, I mean decompose. So for example, aniline if I have, so whenever treating this aniline NH2 with HNO2, it will be forming benzene diazonium ion like this. Okay, if it is salt, it will be forming benzene diazonium chloride. So if it is exposed more than this 300 Kelvin temperature, so here breakage like N2 gas will be evolved out, removed out. So I can say first statement is correct, okay, but second statement is incorrect. Okay, second statement, where is it? So second statement is incorrect. Statement 1 is correct, statement 2 is incorrect. So you can go with option number 4. Okay, then next, which one of the following is suitable to synthesize chlorobenzene? So we need to prepare what? Chlorobenzene we need to prepare. So in order to prepare this, if we are heating like aniline with HCl, there is no use because it is a base, this is acid, therefore acid base reaction takes place and forms like this NH3 plus Cl minus, that's it, no further reaction. Here when we are taking benzene, yes, take it benzene, then next here we have chlorine Cl2, okay, and on the arrow mark you should write FeCl3, that is anhydrous form. Okay, so this is a Lewis acid, so whenever it is reacting with chlorine Cl2, so it will be having FeCl3. So here these things will goes out and will give us Cl plus. Okay, so this is the electrophile, and here we have benzene pi electrons are there, that pi electrons will take this electrophile and forms chlorobenzene. So this is nothing but aromatic electrophilic substitution reactions. Okay, so I explained about this in haloalkanes, haloarenes chapter, which it is very clear in that, so you can watch that video if you are not aware of this kind of reaction. So what is a suitable method of preparation here? Benzene with chlorine and anhydrous FeCl3. So if we treat phenol, this is not the suitable one again. Okay, so there is no reaction between benzene and HCl, so it is not affected, benzene will not affected by this, therefore only option 2 is most appropriate answer for this particular question. Next, identify the incorrect statement for the following. Okay, lithium is the strongest reducing agent among the alkali metals, right only now. So lithium is having more negative reduction potential value, therefore it is considered to be strongest reducing agent, right? Okay, what is the strongest oxidizing agent then? It will be fluorine. So fluorine oxidizes others, and reduces itself, therefore we can say it is strongest oxidizing agent, and lithium is strongest reducing agent. You can remember these 2 points. Okay, next, alkali metals react with water to form their respective hydroxide. Yes, this is also correct now. For example, sodium metal is there, whenever it is treated, whenever it is like placed in the water gives exothermic reaction and forms NaOH plus H2 gas is liberated here like this. Okay, you can understand this. Okay, the next thing is oxidation state of K in KO2 is +4. No, all the times it is a very basic thing now. All the times alkali metals, in all the cases alkali metals, that is first group elements will be showing maximum oxidation state of +1. Okay, they will always show +1 oxidation state in their compounds. Okay, whenever sodium is involved in some reaction, the respect to compound, if sodium like any alkali metal is present, that will be having +1 oxidation state. Even in this reaction also it is having +1. So similar to that, potassium is also having, here it is having +1, and oxygen in this, so this is also important. So +1 for potassium, and for oxygen it should be O2 -1. Okay, like this. So whenever, so this should be +1, it is given as +4, so it is wrong. So option number 3 is incorrect. It means you should choose that option for this particular question. And ionization enthalpy of alkali metals decreases down the group. I just now explained when I am discussing about photoelectric effect. Now down the group size increases, ionization energy decreases, right? Easy to remove the electron, therefore used in the photoelectric effect because of their low ionization enthalpy. Yes, this is also correct. So incorrect statement is third one, which you have to choose for this particular question. Next, so KO2 is given. So in this, whenever oxygen is having -1 charge, O2 molecule with -1 charge, we should say this as superoxide. Superoxide. Okay, so superoxide will be having -1 charge for molecule. So what is the oxidation state of each oxygen atom in the superoxide? It will be -1/2. Okay, for each oxygen atom it will be -1/2. For molecule it is -1. I hope it is clear. Next. Yeah. So tell me here, which of the following is not an aromatic compound? Yes. So how can we identify which of the following is not an aromatic? Not an aromatic. So what are the 4 conditions we have for aromatic nature? Compound should be cyclic. It should be cyclic. First condition. Next, it should be planar. Second condition, it should be having complete conjugation should be there, and it should follow Huckel rule, that is 4n + 2 pi electron should be present, right? These are the 4 conditions should be satisfied. Okay, first one, look in the first question itself, it is having cyclic structure, first rule is obeyed, but second rule, on this carbon we have sp3 hybridization, right? At this carbon we have sp3 hybridization. So whenever we have sp3 hybridization, that carbon is non-planar, therefore this molecule, overall molecule will be non-planar. So the second condition is not obeyed by this first option, therefore this is not aromatic. That's it, simple. Okay, the remaining options you can check, it is cyclic, planar, complete conjugation is there. So this is aromatic, this is also aromatic, this is also aromatic. So first option is not aromatic, therefore you have to select first option as this answer for this particular question. So option 1 is a answer for this question. Next, so whenever they are giving electrode potentials like this, and they will be asking us to identify which reaction is possible, which reaction cannot occur. See, reaction which cannot occur. So looking at the reduction potential values, we need to answer this kind of question. Okay, so now look at here, copper +2 to copper, it is given. So this is what reduction process, right? So reduction potentials are mentioned here. Okay, the one with more reduction potential, more E0 reduction will undergo reduction easily. If it is having more reduction potential, what I am saying, if it is having more positive reduction potential, so the one with the more reduction potential, it will undergo reduction easily. So one with more reduction potential, it should undergo reduction easily, and it will not undergo oxidation easily. Okay, so reverse, like that you can understand. Okay, here reduction potentials are mentioned. Look in the first option. So Cu is converting into Cu plus Cu plus 2 is converting into Cu0. It means copper plus 2 is undergoing reduction, and here Ag converting into Ag plus, it is undergoing oxidation. Now identify if copper plus 2 to copper, if copper is having more reduction potential, so this reaction is possible. So just compare copper. Copper is the first one in the given options and Ag is the last one. So first value is for copper. What is the value? 0.34, and for silver it is 0.80. So which value is more? So which value is more? The silver value is more. Now reduction potential for silver is more. So it means the reaction is not proceed because copper, see here they mention copper is undergoing reduction, but the one which is having more reduction potential value, that should undergo reduction, not the other one. Silver is having more reduction potential, so silver only will be in the reduced form, not copper. Therefore this option will be the suitable answer for this question, because they are not asking, not showing the reaction cannot occur. So first reaction cannot occur because of more reduction potential value of silver than the copper. Therefore silver only remains in the reduced form, not the copper. Okay, I hope it is clear. Okay, let us understand with the second option also. Here copper plus 2 converting into copper 0. Okay, so what is the reduction potential for copper plus 2 to copper? Mentioned it as 0.34 volt. For zinc, how much it is mentioned? Zn plus 2 to Zn. So it is mentioned as for zinc minus 0.76 volt. The one which is having more reduction potential, that will undergo reduction easily. See, copper is having positive reduction potential which is greater than this zinc. Zinc is having negative, so positive values is higher now. So copper only easily undergoes reduction. So this reaction plus to copper converting into 0 form, plus 2 is converting into 0. So which means this reaction is possible, right? Therefore this is correct only, this reaction will take place, but not the first option. Like that we have to choose. Okay, I hope it is clear without any confusion. Higher the reduction potential value, that will undergo reduction easily, that's it. Okay. Given below are two statements. The acidic strength of monosubstituted nitrophenol is higher than the phenol because of electron withdrawing group. Yes, statement is correct. Electron withdrawing group containing phenols are more acidic than the normal phenol. Okay. Orthonitrophenol, paranitrophenol and metanitrophenol will have same acidic strength. No. Okay, because mesomeric effect will be observed only at ortho and para. Therefore ortho para nitrophenols will be having more acidic nature than the meta. Therefore this option is, statement 2 is incorrect, statement 1 is correct. So statement 1 is correct, statement 2 is incorrect. So fourth option is correct. I hope it is clear. Okay, which of the following statement is not correct about diboron? So it is easy. Again, if you want to study more about diboron, so I have made a 10-minute video, specially on diboron. So in the golden minute series there will be a 10-minute video which is specifically for diboron discussion. Okay, I think I tried to cover everything regarding diboron, which is very useful for upcoming EAP set. Okay, which is very useful for upcoming EAP set. If you have time, just go and watch this 10-minute video, that will be helpful. So you can simply answer after watching that video. Okay, see, boron in diboron will be having sp3 hybridization. There are two boron atoms, B2H6, two boron atoms, each will be having sp3 hybridization. Again, so in this diboron, like this structure will be there. Okay. Okay, like this. So each boron is sp3 hybridization, but they are saying sp2. Not correct. Directly go with the first option itself. Okay. Second structure, it has 2 3 center. Yes, 2 3 center. This is 1 3 center. The second one is this 3 center. So this is statement is correct only. Like that, if the 2 3 4 options are correct, but not the first one. So first one you should choose as the option for this particular question. Okay. So if you want to know about diboron, go and watch diboron in the playlist as golden minute series, it is mentioned. Okay. So now boiling point of the aldehydes, ketones are higher than the hydrocarbons. Yes, because aldehydes, ketones are more polar than these hydrocarbons, okay, of comparable molecular mass because of weak molecular association in diborane ketones due to so due to dipole-dipole interaction, aldehydes, ketones will be having more boiling point than respective hydrocarbons with the similar atomic molecular masses. Second statement, the boiling point of aldehydes and ketones are lower than the alcohols, okay, alcohols of similar molecular mass. It is due to absence of, yes, in alcohols hydrogen bonding is present, hydrogen bond is present, therefore due to the hydrogen bond there will be strong intermolecular forces of attraction between the alcohol molecule, which makes it to exhibit more boiling point when we compare with the respective aldehydes and ketones. So both statements are correct. So both statements, statement 1, 2 are correct. Yes, second option. Given below are two statements, one is labeled assertion, other labeled reason. ICL, so always remember interhalogen compounds. For example, halogens means something like X2, like Cl2, F2, Br2, I2, like that. So always remember interhalogen compound. It means two different halogens, two or more different halogens, like see ICl I am writing. So they mentioned ICl. So interhalogen compounds are more reactive than the normal halogens. So always remember interhalogen compounds are more reactive when compared with the normal halogens, okay. So here ICl is more reactive than I2, this is correct, okay. So when we compare with I2, F2, Cl2, all these things, F2 is more reactive than all other halogens. Now if I compare halogens with interhalogen compounds, all interhalogen compounds are more reactive than all the halogens except fluorine. Okay, you can remember this statement. Fluorine is more reactive even when we compare with the interhalogen compounds, okay, except fluorine. If we compare interhalogen compounds with the halogens, interhalogen compounds only more reactive, okay. If we compare fluorine with interhalogen compounds, fluorine is more reactive. I hope it is clear, okay. So first statement is correct, ICl is more reactive than I2, yes, this is correct only. ICl bond is weaker than II bond, okay. Yes, that is also correct. So I can go with so A is not correct, no. So both A and B are correct and R is the correct explanation of A, so you can go with that option. Next, so what kind of products are formed here? That is the question asked, okay. So they mentioned reaction with reaction of carbonyl compounds with products formed, okay. Carbonyl compounds, CO, this is a carbonyl compound that should be reacted with these compounds, then what are the products formed? So always remember, so whenever HCN is added to carbonyl compound, it will results to form, see HCN, what is the formula? HCN. So whenever this is added, this is a weak acid, H plus Cn minus. So this will results to form cyanohydride. So it means these are the carbonyl groups, okay, alkyl groups. So here this goes like upside, O negative, that negative and this H forms OH and Cn minus, like this. This is called cyanohydride, A4. So do we have any option? A4, only one option is there, that is correct, okay. Next, so whenever carbonyl compounds reacting with alcohol, they will results to form acetols, so B3, okay. Next, whenever amines are reacting with carbonyl compounds, forms Schiff's base, okay, and hydroxylamine forms forms oximes. This is hydroxylamine forms oximes. Okay, next, B2H6 is electron deficient, okay. Mg, so here next, how many hydrogens are there, like electrons are there? So it is four valency electrons around the like see, this is carbon family, na, like carbon, silicon, germanium, okay. Now 4 valence electrons, so 4 hydrogens around, so it means it is electron precise. So you can choose C2, okay, C2 and B1, C2, B1, Okay, B1 is not there. B, C2, B1, yes, here it is there, C2, here also it is there. So we can eliminate first option and fourth option. So from 2, 3 we need to identify. Okay, now magnesium hydride. So we know alkaline earth metal magnesium, it will be Mg plus 2H minus. So this will be ionic compound. So I can go for this one. So A4, yes, sorry, A4, yeah, see here A4. So it means second option is more correct here. So whatever the options we are much aware, so go with that. See, I mean just eliminate using the like things you know. See HF will be having electron rich, I mean on fluorine we have non-bonding electrons, no? That is what he is saying here. So we can go for this one, D3, okay, and A4, that's it. Okay, I hope it is clear, no confusions. Okay, next, gadolinium. Gadolinium is having what is electronic configuration? 4f7, and the next is 5d1, 6s2. This is the electronic configuration of gadolinium. Okay, so they are saying third ionization energy, enthalpy. Okay, third means after removing this, that is first if we remove first ionization, second ionization, third means this one should be removed. That ionization energy is low, they are saying. Why it is low? If we remove this 3 electron, the third electron also, we will be having 4f7 half filled f orbital, which is stabilized by exchange energy. So whenever we have half filled and full filled orbitals, that will be more stable, and this is stabilized by what? High exchange enthalpy, which is correct option here. Next, this is again easy question. So antimicrobial drugs, this is what? Salvarsan. Antacid is what? Cimetidine. Next, based on these options you can just check once. A3, yes, these two options are there. Antimicrobial, D1, here also these two are D1, yes, these are there. Next, antihistamine, so this is analgesic is morphine and antihistamine is Seldon. So it means B4, yes, B4 here we have. So option number 3. Okay, I hope it is clear without any confusions. Okay, morphine is here, C. Next, Jayal's method, which is again important. Jayal's Dumas method. If you have time, you can go through Jayal's and Dumas method. So Jayal's method is used to estimate nitrogen. So how much quantity of nitrogen present in a given organic compound is estimated by Jayal's method and Dumas method. Okay, so this Jayal's method will not be work whenever there are in some compounds, those compounds are given here. So in which of the following, see, estimation of nitrogen can be estimation of nitrogen can be used to, see, Jayal's method is used to for estimation of nitrogen. Okay, the amount of nitrogen, okay, to estimate the amount of nitrogen, one of the following compounds. Okay, so in the given 4 option, so in which of this compound we can estimate how much quantity of nitrogen present in the given compound for the 4 options he is asking. So Jayal's method will not work whenever there is a bond like this, diazo bonds, like azo bonds are there. So in that case it won't work. So it means it won't work here. So whenever we have nitro groups, there also Jayal's method won't work. And whenever we have nitrogen atom involved in the cyclic rings like this pyridine, pyrrole, it won't suitable to estimate nitrogen in this compound. Jayal's method is not suitable to estimate like quantity of nitrogen present in these compounds, azo compounds, nitro compounds and cyclic ring, nitrogen present in the cyclic ring. So first 3 we won't able to find. It should be, nitrogen should be like this, placed freely, so that can be found only in the, that can be estimated only in the 4th option. Okay, I hope it is clear without any confusions. Next, diamond and graphite, this is also important question. See, diamond, graphite are used as lubricants. So we know graphite only used as lubricant but not diamond. Okay, next, diamond graphite have a two-dimensional frame, two-dimensional network. No, they have three-dimensional framework, right? Diamond, so which is correct statement they are saying? Okay, diamond is covalent, graphite is ionic, both are covalent. Okay, diamond is sp3 hybridized, yes, it is having tetrahedral hybrid like geometry between the carbon atoms. Okay, next, hybridized, and graphite is sp2 hybridized, yes, fourth statement is correct, first three are incorrect. Okay, what is the IUPAC name of this complex? See, so whenever we have two coordination sphere, first give the name for cationic sphere, then give for anionic sphere. Okay, now for example NaCl is there, we are writing the name for sodium, then for anion, first cation, next anion, sodium chloride. Here also same story. Okay, now try to identify the oxidation state of metal here. So aqua molecule is 0, oxidation charge of aqua molecule is 0, therefore in this case if we consider it will be 0, right? But here if we consider Sn, cyanide ion is having Cn minus, like that two ions are there, it will be -2, therefore silver should have +2. So but silver exists with +1 stable oxidation state, therefore give that +1 to here one, and for this one also +1, therefore both silver atoms are in +1 oxidation state. Okay, now whenever we are writing name for cationic sphere, okay, so all the cases first write the names of ligands, then followed by metal. Okay, so I can write diaqua. So for Ag we should say silver when it is in the cationic sphere. Okay, diaqua silver 1. Okay, diaqua silver 1. Here only we have only the first option. Okay, then next, say when we are writing the second sphere, so leave a space, see some space is left here. Okay, next, dicyano or dicyanido. Silver when it is in the anionic sphere, you should call it as argentate. Okay, the name itself indicates whether it is in the anionic sphere or cationic sphere. Okay, dicyano argentate, here it is also having +1. Write the oxidation state in the parenthesis bracket. Okay, so first option is most suitable for this. Okay, next, so whenever we have PV curves, PV works isothermal, adiabatic, so whatever it is, PV curve is there means, so just take how to find the work done. So just check the area covered under the curve. So maximum area covered under the curve, maximum will be the work done. See here in this graph, maximum area is covered, so maximum work done is in this third option, in this option. So this is first one, second one, this is third one. So this option is correct, that graph is correct. In 1 molar solution contains 0. What is the molality formula? Number of moles of solute present in 1 kg of solvent. Okay, so now what they are saying, 1 molar solution that contains 0.5 mole of a solute, there is in the solvent. How much solvent they are asking? Okay, so in order to find that, so can I take it as weight of solvent into 1000, so that I can express weight of solvent in grams. Okay, here I am writing. So weight of solvent, if I take it this side, so weight of solvent will becomes how much? 0.5 into 1000, it will be 500 grams. That's it. This is the answer. So option number 3. That's it. Very simple questions are there. Okay, now here identify the incorrect statement from the following. Okay, the shape of dxy, dyz, dz square are similar to each other. Yes, correct only. Dx square, dy square, see why I am saying they are correct, they are in between the axis xy, yz, zx. So therefore in between the axis, if this is y, this is z axis, so it will be like this, it will be like this. So in between the axis, so similar to these other also. So first three are same, but next one dx square will be along the axis. So if this is y axis, it will be like this, and if it is if it is x axis, it will be like this. Okay, along the axis this is. Okay, now whenever saying dz square, so if this is z axis, it will be like this, and other one lobe will be like this, like a donut. Okay, so these two are not similar. Okay, dz square y square and dx square y square and dz square, these are not similar. Okay, therefore option 1 is incorrect. Okay, next, all 5 d orbitals are different in size. 5d orbital, all the 5d orbitals are differ in the size when compared with the respective 4d orbitals. So just incorrect statements they are saying, no? Okay, let us keep this second option aside. All the 4d orbitals have shapes similar to 3d orbitals. See, shapes are given by what? Shapes are given by principal azimuthal quantum number, that is what? L, or angular quantum number. So if the L value is 2, then we are saying it as d orbital. Okay, so whether it is 4d, 3d, 5d, whatever it is, if L value is same, it means all the d orbitals will be having same shapes. Okay, that should be clear. So second statement is correct. They are asking about incorrect one, right? Yeah, anyways, we got in the first option itself, na? So first option is incorrect, that is incorrect. You can choose first option as the answer for this. Okay, in an atom, all the 5 3d orbitals are equal in energy. Yes, in the free state. Yes, that is what we are saying, degenerate orbitals. So this is correct, this is correct, this is also correct. Okay, remember 5d orbitals when we compare with the 4d orbitals. Okay, so due to the increase in principal quantum number, their size increases. That's why the second statement also correct. Only the incorrect statement here is first one. Okay, whenever they are asking about shape, you should look for the L value. Whenever they are asking about size, we should look for the L value. Shape, size, if they ask, look for the N value. Higher the N value, higher is the size. So when they are asking about shape, you can look for the azimuthal quantum number L values. Okay, so for a particular L value, shapes will be same. Next, this question I haven't explained. Yeah, this is also important. CaCO3 will be required. What is the quantity of CaCO3, mass of CaCO3 required to neutralize this one? Let us say CaCO3 reacting with HCl forms CaCl2, right? CaCl2 is formed. So for every 1 mole we require 2 moles. So it's something like a neutralization process only, no? So this quantity is given, this much. So how much quantity of this is required, they are asking. So you use law of equivalence here. Equivalence of CaCO3 equals to equivalence of HCl. That's it. Okay. So equivalence I can write normality formula, number of equivalence, GEN we are writing now, number of equivalence by volume we are writing. Okay. So if I want to find equivalence, can I write N into V? Means N means normality, V means volume. So I am writing here N into V of HCl. So I can write equivalence as N into N factor also, number of moles into valency factor. Okay. For this I am writing N into N factor. Okay. Now here N into V should be in what? Liters. If it is in ml, we should multiply with 1000. So what? I want only equivalence now. So send remaining things to this side, N into V by 1000. So I am writing here N into V by 1000. Okay, up to here I think it is clear. Now substitute the given values. See, they given 0.1, 0.5 molarity. So molarity and normality here it is same because N factor for that particular HCl is 1. Okay, so I am taking it as 0.5 into volume is given as 50 by 1000. Okay, this is done. And here N factor for CaCl2, calcium, CaCO2, calcium always here it is in +2, right? So it means it can take 2 electrons or lost 2 electrons. So I am taking N factor as 2, and we need to find weight. Number of moles we can write as given weight by atomic weight, right? So I am writing given weight here, given weight. We require to find that given weight only. Okay, by what is the atomic like molecular weight of CaCO3, that is 100. Okay, now it is not completely pure, it is 95%. How much it is pure? Multiply with that 95% like this. Okay, so if you do this, so we will be having, let us check once. So these I can write 25. So 0 0 0 0. Okay, next here we have 5 0. Then next we have 5, this is 19. So weight will be 25 by 19. Okay, so this will be 1 point. So it is 6 is remaining. Okay, 60. So 3. So 1.3, which is having option number 3. 1.32 will be the answer. Okay, I hope it is clear without any confusions. Just look and give a try from your side once again. So this kind of questions may be taking time, but this is the mark or rank deciding questions. Okay, because most of the students will stuck in the numerical based questions only, right? Most of the NEET student will scare when it comes for physics and chemistry whenever they involve more calculation part. I hope you got what I am saying. So you should not skip those kind of questions in order to score better, in order to get better score and better rank. Okay, so please give a try from your side once again, or you can give a try and rewatch it so that you will get some clarity on this kind of questions. Okay, so O2 is O2 plus is diamagnetic, he is saying. See, on MOT I have made wonderful video. If you watch this, I hope you will definitely going to attempt whatever the question comes from MOT after watching that video. So just go through the playlist where I have made a special video on MOT and special video on valence shell electron pair repulsion theory. Both videos are highly helpful. Okay, so now O2. So whenever they are saying O2 molecule, it is paramagnetic, it is having 2 unpaired electrons. Okay, paramagnetic I am saying it is having 2 unpaired. So if it is O2 plus, now it is also having, see, from 2 unpaired electrons we are removing 1. So it means 1 unpaired electron is there now. So this is also what? Paramagnetic. But he is saying diamagnetic. So first statement itself incorrect. So you can choose first option. Okay, the bond orders of O2, O2 plus and O2 minus are O2 2 minus are. For these O2 we know bond order is 2.0. So for 16 electrons remember 2.0. O2 plus means 15 electrons, it is 2.5, just increase by half. Okay, so O2 minus means decrease by half, 1.5. Here again decrease by half. Okay, it is 1.0. So second statement is also correct. C2 has, yeah, this is also correct, this is also correct. Okay, so whenever we are adding RMGX to CO2, yes, this is important, very important. I will tell you 2 differences here. RMGX, whenever we are adding to CO2, we can write like this. So this will results to form R, see, R minus will attack on this carbon and forms carboxylic acid. Okay, O minus MgX. So this is what the product formed. Okay, Grignard reagent with CO2 forms carboxylic acid, salt of carboxylic acid. So second statement is correct. Okay, and hydrolysis gives carboxylic. So this is the carboxylic acid. Okay, now same CO2, same carbon dioxide, when we are treating this with alkyl lithium, some other product is formed. So try to answer what kind of product we will be seeing when we are treating with alkyl lithium. Okay, so you can answer in the comment box if you know. So you just give a try. If you are giving wrong answer, then I will help you there. So but at least you should try for that. Okay, so now given below are 2 half cell reactions. So these are the 2 half cell reactions given. This is one reaction, this is another reaction with their standard potentials. Okay, this is oxidation potential, this is reduction potential is given. Okay, will the permanganate ion, that is what MnO4 minus, okay, liberate O2 from water or not? They are asking this question. So when these reactions happen, so whether this O2 is released from this water or not. So just write the opposite reaction here, H2O giving H2H plus O2 half O2 plus 2 electrons are released. If this is a process, so E naught of H2O to O2. I mean, I am writing this reaction is reverse, then equally like this value reduction potential also will be reversed. It means it is, see here I am writing oxidation potential, here they are given reduction potential. So I am writing these oxidation potential as negative 1.223 volt. Okay, I hope it is clear without any confusion. This is the reaction they given, I just reversed it because based on their statement I have written that. Okay, so if reaction is reversed, then sign becomes like opposite. If it is positive, that will become negative value. Okay, up to here it is clear, I hope. Up to here it is clear, I hope. Next thing is here manganese. Yeah, so in this process this is what happens, it should be oxidized, no? So in the first case it should be, in order to make it oxidized, it is losing 2 electron. That 2 electron has to be taken by this manganese. It means manganate ion, permanganate ion should undergo reduction. Okay, so in order to have move this process, permanganate ion should undergo reduction, therefore it will undergo oxidation. So it means it should take this 5 electrons, okay, Mn plus 2 plus 4 H2O they given. Okay, so now what is the value they mentioned for this? See, this is reduction now, so this is mentioned as E naught Mn plus 2 to Mn plus reduction. So this is reduction. So for this reduction, see, it is undergoing reduction, but here they mention oxidation value. So it should be, I am taking the opposite of this because it is undergoing reduction. Na? So I am taking based on the reactions. Okay, so it means I should write the value E naught of Mn plus 7 to plus 2, Mn plus 2. What is the value they mentioned? It is minus 1.50510. So I should write here it as plus 1.50. So just to avoid the confusion, I am making in this manner because I am writing with respect to the statement they mentioned. Okay, like this they have mentioned. Okay, if we find E cell, E naught cell will be given as E naught of, see, we should write it as E cell equals to E naught oxidation potential at anode plus E naught reduction potential at cathode. So this is how we need to write. Okay, from this only we can get other equations also. In the books generally we will be seeing this kind of equation, na? E naught cell equals to E naught cathode minus E naught anode. This is what we will be seeing, because in the books they will give reduction potentials only for both, for cathode and anode they will mention only reduction potential. Here whenever we are writing oxidation half, reduction part, we can also write in this form, E naught potential in terms of oxidation and also E naught in terms of reduction potentials also. Okay, in this case you should use the positive symbol, in this case you can use negative symbol, that's it. Okay, now here tell me what is the E naught oxidation potential. So this is minus 2 is converting into 0 now, so I can take this as minus 1.223 volt plus E naught reduction is how much? So this is undergoing reduction now, so this is plus 1.510. Okay, so from this what we can get? So we can get something like around 0.07. See, it is 0.7. Okay, so we have positive value only because this is bigger value, so we will be getting plus 0.287 volt we are getting. Okay, so whenever we got E naught cell value in the terms, positive terms, yes, reaction takes place and it is a spontaneous process. Okay, yes, reaction happens because E naught cell is positive value, therefore a reaction happens. If E naught cell is negative value, reaction won't happen, but we got a positive some value, right? So it means yes, the process will happen. Like this you should answer. Okay, there are many ways to solve this kind of questions, but I think I have explained from very basic. Okay, the given graph is representation of kinetics of a reaction. Okay, so given y and x as a like coordinates. So now the y-x axis for 0 and first order reactions respectively they are asking. So how can we identify this kind of things? So look here, if on 0 order reaction, if y is rate, So rate of a reaction for zero order reaction is directly proportional to concentration of substrate, but it is zero order like this. So rate is independent of concentration of substrate. So if it is rate, it is independent of concentration. Yes, it will be like this. Okay, so I can say rate and concentration. Yes, for first order it is correct, zero order it is correct. For first order, rate is directly proportional to concentration of substrate to the power 1. This is for 0, this is for first order. Okay, so for rate should increase with increase in concentration of substrate in case of first order. Okay, but it should be independent. No? So for a T half for first order reaction is independent of concentration. This is given as 0.693 by K. This is for the first order T half. Okay, half life of a first order reaction. Okay, so that should be, so here rate Y is this one, this is correct. So for zero order reaction, for first order reaction, Y should be rate, not rate here, it should be concentration and T half. Concentration and T half, it is there here. No, yeah, Y should be T half and X should be concentration. Yes, this is correct. Yeah, so you can go with this option. Okay, fourth option is most appropriate based on these relations. So what about chirality in SN1 and SN2 reactions? So if a chiral center is there, so in the SN1 reactions, racemic mixture is formed. It means equimolar mixture of two enantiomers are obtained. Yes, so SN1 reaction yields 1:1 mixture of enantiomers. This is correct. Okay, racemic mixture shows zero optical rotation. Yes, this is also correct. The product obtained on SN2 reaction of haloalkanes having chirality will have inversion of configuration. This is also correct. Fourth statement, enantiomers are superimposable mirror images. No, these are non-superimposable mirror images. So fourth option is incorrect. So you should choose this. Okay, about SN1 and SN2, there is a very nice video which I have explained everything related to mechanism part. Okay, so you can watch that for more information. Okay, I hope it is clear. Enantiomers are non-superimposable mirror images, but they are saying just superimposable. They are not superimposable. See, what do we mean by superimposable, non-superimposable? For example, this is a molecule. Here I am placing one mirror. So let us imagine here we have a mirror. Okay, the mirror image of this molecule will be like this, right? Okay, now bring this molecule and place it on its mirror image like this. So if the fingers are like merged, for example here it is little finger but here it is index finger, so it means they are not superimposing. This is non-superimposable mirror image. Okay, if the index finger is merging with index finger, then we can say that is superimposability, but it is non-superimposable, right? So these two compounds, now these isomers like this compound and this compound, this substance and its mirror image, these are what? Non-superimposable mirror images. So now I can call them as enantiomers. I hope it is clear. Okay, so now 119, what we can say 119 means in IUPAC nomenclature we should write 1 as un, again un, first U, you use capital U, NEM. NEM. So we have option number 2, that's it. Next, which is not correct regarding the polymers. See, thermosetting polymers are reusable. No, they are not reusable. Na? So whenever we are heating, the cross linkage like many cross linking takes place, therefore it cannot be fusible. It will be infusible material, therefore it cannot be reusable. So incorrect one is first statement itself. Okay, remaining all are correct only. So boiling point, what happens for the hydrates of group 16? So down the group, boiling point, what happens? Decreases, because H2O will be having hydrogen boil, like, see, actually it depends upon molecular weight also. See, increases with molecular weight also, but here the impacting thing is H2O is having hydrogen bond but H2S is not having. So H2O will be having more boiling point than H2S. So I can say first statement is incorrect, second statement also incorrect. So both are incorrect. So third option. Which will be having maximum lone pair repulsions. Just find hybridization of each of these. So for first one, 8 xenon group number is like valence electrons are 8, surrounding atoms are 2 by 2, so 10 by 2, 5. So out of 5, 2 are bonds and 3 are lone pairs. So out of this 5, 5 means sp3 dehybridization, right? So I am saying out of this 5, surrounding atoms are 2, so it will be forming 2 bond pairs, and the next 3 are lone pairs. So between these 3 lone pairs in the trigonal bipyramidal geometry, so repulsive interactions are at 120 degrees, right? Okay, 3 repulsive, like 3 equatorial positions we have 3 lone pairs, right? So it means it will be having maximum lone pair repulsions when we compare with the others, because this is also having trigonal bipyramidal geometry, but it is having 3 bond pairs, 2 lone pairs. Here lone pairs are more, therefore more repulsions in the first case than the second case. Okay, so for this you will be having 1 lone pair, for this you will be having 1 lone pair. So the minimum repulsions, maximum repulsions will be in the first option. Next, for a first order reaction, initial concentration of A is 0.1 and becomes 0.001 after 5 minutes. It means what is the rate constant? K for first order reaction we can find 1 by T. So you can use this formula 2.303 by T log initial concentration A naught by final concentration at time T, concentration at time T, like this we can take. Okay, so after 5 minutes, time is 5, 2.303 log, what is the initial concentration given? It is 0.1, so I am writing 10 power minus 1. Okay, this is 0.001, I am writing it as 10 power minus 3. So this will be 10 power 2, so 100 I can write. So log 100 I can write 2 log 10, log 10 is 1. So I am writing it as 2.303 into 2 by 5. Okay, for this is what we got here now. So I am writing this as 4.6 by 5. 4.6 by 5. So this will be 0.9. So we have only option number 3. Yes, this is how you can able to solve it. Next, which one of the following is not formed when acetone and 2-pentanone? Acetone structure is this one. I will tell you one trick for this. So just follow whenever you have like aldol condensation reaction. See, so these two things we need to react with the dilute NaOH. So alpha hydrogens if present, we can expect for aldol condensation. So how can we identify the product formed from this? Yes, this is what cross aldol product. So whenever we have cross aldol, so we can get reaction from this one. Let us say this is A, this is B. We can get AA type product, BB type product, AB type, BA type, like that we can get different number of possible products. Out of this, which is not possible, they are saying. Okay, so look here. So what happens? From one carbonyl group, 2 hydrogens are removed from alpha position carbon, and the other carbonyl group oxygen is removed. Therefore totally water molecule is removed. So if I break a bond here, so wherever you are seeing the double bond, just break that will be the trick here. So here if we break this side, so I am putting here oxygen, this will be the acetone, this part, and the remaining part is what? Like this. Here we are removing 2 hydrogens, CH3, CH3. So 1, 2, 3, 4, 5. This is 2-pentanone only, na? Yes, this is possible. Okay, now from this again break this. This is acetone part. What is the remaining part? 1, 2, 3. That is also acetone part. Okay, between AA this kind of product is formed. This is also correct. Okay, next here if you break this one, so what is the expected product? Like this. Okay, what is the remaining this side species? So yeah, CH3, H and H. Just break the double bond. One side you place double bond O. So which side we should place this oxygen? See, already here carbonyl group is there na. The alpha positioned hydrogen of this carbonyl carbon will be acidic hydrogen. Those are involving in the reaction. So it means carbonyl group adjacent carbon should contain hydrogen. So this is what the hydrogen. The other side of the double bond should contain oxygen. That's it. Okay. This one and this one. So now count number of things, carbons 1, 2, 3, 4, 5. See, the carbonyl position here is 3, but they mention it as 2 pentanone, but this is 3 pentanone. So therefore option 3 is not possible product in this reaction. So should choose option 3. I hope it is clear. Okay. So whenever we have KMNO4, okay, so in acidic medium if the reaction is taking place, so Mn plus 7 oxidation state converts into Mn plus 2, remember this directly. So whenever we have slightly alkaline medium or neutral medium, so slightly alkaline or neutral I am writing, so it will converts into Mn plus 4, okay. If it is strong basic medium, strong alkaline, it will be converts into Mn plus 6. So based on this explanation you can directly choose plus 7 to plus 4. So option number 2, right. That's it for this question. So compound X on reaction with ozone and Zn water gives formaldehyde. Yes, every time there will be one question on this ozonolysis topic. I have explained everything clearly using the trick for this ozonolysis and hydroboration, everything from the hydrocarbon. So you can go and watch hydrocarbon chapter if possible. Okay. So this is formaldehyde and another one is propanol, 2-methyl propanol. So propanol means 3 carbons, and the last carbon I am writing aldehyde, and 2-methyl means like this. Okay. So what you need to do this, just go back from here. So this is ozonolysis means O3. Okay. So just remove this oxygen and connect them, that will be the alkene. So what is the part? We have hydrogen, this is the compound. So this is simple. 1, 2, 3, 4. How many carbons are there here? 2-methyl propanol means 1, 2, 3 at second position. Yes. This is formaldehyde. Yes. So 1, 2, 3, 4. Yes, that's it. Okay. So I can say 3-methyl 1, 2, 3, 4. No, 3-methyl but 1-ene. 3-methyl but 1-ene. So second option is the correct. I hope it is also clear. Next. So this is again easy question. Kc we need to find. Kc is also given for the above reaction. Concentration of O2 at the equilibrium is also given. Concentration of O3 we need to find. So whenever we are writing Kc for a particular question, so how can we for a particular equilibrium reaction write concentration of product to the power their coefficients. So it means O3 concentration to the power 2 and O2 concentration to the power 3. This is how you need to write. Okay. So Kc value they given as 3 into 10 power minus 59, right, and O2 is given as 0.04. So I am writing 4 into 10 power minus 2 whole cube, and we need to find O3. That's it. So just send this side and simplify this, you will get one of the option from the 4. Okay, easy. Next, Bohr model. What is the formula for Bohr model? Radius, Bohr model, from Bohr model we have radius formula. So Rn, radius of nth orbit, given as 0.529 n square by z, right? Angstroms, units are angstroms. So using this we can write radius of nth orbit is directly proportional to n square by z, right? So based on this you can solve this question. See, they are saying second Bohr orbit of helium. Okay, so R2 of helium plus, okay, we can write it as R2 of helium plus, here I am writing helium ion is that much. What is the radius of third Bohr orbit of lithium? R3 of Li plus 2 is equals to. So how can I make for this What is the n value? N value is R2. It means n is 2 square. What is the atomic number of helium? That will be 2. You can write here. Okay. Now write about lithium. R3. N value is 3. So 3 square. And what about atomic number? That is 3. Okay. 3 square. 2 square. So we are remained with what? So 2. So here I can write. So what we can write? So here, so we can write 2 by 1 into 1 by 3. So 2 by 3 we can write. So just take it in the numerator side. Okay. So we need to find for lithium now. So what is the value for helium they mentioned? So they mentioned for helium as 105.8 picometers, right? Okay. In the denominator we have now send this here. So R3 Li plus 2. Okay. After knowing this, just multiply here and divide by 2. So 3 into 105.8 by 2. That's it. This will be the R3 of Li plus 2. Okay. Solve this. You will get one of this option. Okay. So you can give a try from your side. Then next, the pollution due to oxides of sulfur gets enhanced due to the presence of what? Okay. Yes. So sulfur dioxide is there now. Oxides of sulfur, let us say sulfur dioxide we can take. So whenever we have particulate matter, so that will oxidizes SO2 sulfur oxides very quickly to respect to acidic oxides like SO3. So this will, whenever it is exposed to water, results to sulfuric acid, which causes acid rain, right? So this will affects, okay, pollution. And ozone will also converts, oxidizes the sulfur oxide to sulfur trioxide, which is also acidic oxide. Again, hydrocarbon have no effect. Okay, hydrogen peroxide also oxidizing agent, so it will also converts into respect to oxides, I mean acidic oxides. Therefore A, B, D will be the option. A, B, D, option 3. Next, so this is very simple. Pressure inside the flask they are asking with the given data. So you can use PV equals to nRT formula. Okay. So now we need P, nRT by we can take nRT by V. Okay. So what is the N value? So for oxygen 64, given weight number of moles is 64 by 32 into R value 0.083 into temperature is mentioned as 27 degrees. So you should take 300 Kelvin. Okay, and volume is mentioned as 10 liters. That's it. You got the answer, 10 liters. Okay, if you simplify this, so we have, this is 2 times. Okay, this is 10, 30 is remaining. So it can be 60 into 0.08 if I take. So it will be 6 into 0.8 if I write. So this will be 4.8 around. So this will be 4.83 is there now. So therefore answer will be 4.9 will be the most appropriate answer for this particular question. What is the IUPAC name? How can we give? So here you can follow lowest, like giving the numbers in the least, like we should give the numbering in the by following lowest sum rule. What is this lowest sum rule? If I number from here 1, 2, 3, 4, 5, 6. Okay, where are the substituents? At first position, at third position, and at fourth position, at fifth position, right? So what is the total sum here we got? So 5 plus 4 plus 5, 9, 10, 13. 13. If I give from here, 1, 2, 3, 4, 5, 6. So tell me the green color numbers. So it will be what? So 1 plus 2 plus, numbers 2 plus 4 plus 2 plus 3 plus 2 plus 3 plus 4 plus 6. So it will be 15. So this numbering, this first method is easier now. So because lower name, this should be followed, but not this. So what we can get? 1 bromo, follow the alphabetical order. 1 bromo, and 2 chloro, not 2 chloro, 5 chloro. 1 bromo, 5 chloro. So where do we have the option like that? 1 bromo, 5 chloro, 4 methyl hexane, 3 ol. Yes, this is the option 2 is the correct. Next, Lucas reagent, Lucas test, primary, secondary, tertiary alcohols are distinguished on the basis of their reactivity. Yes, Lucas reagent is this one known as Lucas reagent. Yes, I hope it is clear. We already discussed in SN1, SN2 reactions of haloalkanes chapter, right? The primary alcohols are more reactive. No, here the reactivity are towards the Lucas reagent is tertiary alcohols are more reactive than the secondary, then the primary, then the methyl. Okay, therefore this second statement is incorrect. Okay, so first statement is correct. Statement 1 is correct. Statement 1 is correct, but statement 2 is incorrect. So option number 4 is correct for this. Next. So order of energy absorbed. So what they are asking, energy absorbed, which is responsible for color of the complex. Yes. So energy absorbed means whenever we are studying about this, so we need to remind whenever they are asking about energy absorbed or wavelength absorbed, frequency absorbed, this thing, you need to get CFT in your mind, crystal field theory. So there where we are seeing splitting of orbitals into two energy level, T2G level, EG level, when it is octahedral complex, right? So now the electrons from this lower energy state excites to higher energy state. So during this process they require some electrons to excite electron from lower energy to higher energy. Okay, so that energy they are talking. Okay, now if the gap is more, the energy gap is more between the lower energy state and higher energy state, it requires more energy to excite the electron, right? Okay, so the splitting, the energy gap depends upon what kind of ligands are present and what oxidation state this central metal contains. Here in this case all the nickel atoms are in +2 oxidation state in all these complexes. Okay, now the ligands are differ here. So in the third case, ethylene diamine is 3 times, 3 ethylene diamine ligands are there, hexa coordinated complex. Okay, here only one, here it is 2. So we know ethylene diamine ene is strong field ligand when we compare with the water molecules. So higher the strength of the ligand, greater is the splitting ability. So 3 ene ligands are there, more splitting will be there, stronger splitting will be there. So therefore it having stronger splitting ability, it means more gap, more energy is required for more energy is absorbed for the excitation of electrons. So I can say C is more, and here 2 ligands, ene ligands, strong field ligands, and here only 1, whereas water molecules are weak field ligands. So the effect of H2O is very less when we compare with the ene. Okay, so 2 strong field ligands, therefore it is having more splitting ability. In option A more energy is absorbed than this C, then this B, therefore C, A, B, CAB. So where do we have? Fourth option, that's it. Next, this is also simple based on the Nernst equation. So easy, simple calculation is required here. So what they are asking, find the EMF of cell. So E cell equals to E naught cell minus 0.059 by n log K. K means concentration of product by reactants. So what is the product here? We have nickel +2. Only ionic forms you should take, solid forms you ignore, activity is 1 for them. Okay, and in the reactant side Ag plus square. Now how many electrons are changed here? See, 2, see +2 is there, 2 is +1 is there, but 2 ions, so it means 2 electrons. Here nickel 0 converting into +2, so 2 electrons are changed, therefore n value is how much here? It is 2. Again, what is the E naught cell value mentioned? 10.5 minus 0.059 by 2 log, what is the nickel +2 concentration? 10 power minus 3. What is the Ag +2 concentration? That is also 10 power minus 3, but power 2 is there. So this 2, this is cancelled. So I can write 0.0959 by 2 log 10 power, like I can write in the numerator, that will become 10 power 3. So I can write 3 log 10, that is log 10 is 1. So here it is written like this, minus 10.5. Okay, like this if we do. So then next, by simplifying this we will get 0.03. So 3 3 is a 9. So this will 10.5 minus 0.09. Okay, so which is around 10, but there is no option with 10 volt. Okay, so I have seen in some other references also, but there also they mentioned this is not answer type question. I mean, there is some like discrepancy in the options, maybe not given proper option for this. So option like answer should be around 10 volts, but there is no option with respect to that answer. So I think this is not the answers are not provided for this particular correct answer is not provided for this question. Okay, and here magnetite, see magnetite, hematite, both are iron ores. Okay, you need to remember magnetite, M is there na, I am saying magnetite and hematite both are iron ores. So M looking like 3 only na, so like inverted 3, so it means it will be having iron 3 times, Fe3O4. So M Fe3O4. Okay, magnetite you can remember like that. Okay, hematite will be having Fe2O3, you can remember this. Okay, so hematite that is over. Calamine is this one, calamine is that one. Then next this one will be 4, D4 is there in this many options. Okay, I told you magnetite Fe3, magnetite Fe3, B1, only these 2 options are there. So first 2 is eliminated, and hematite is 3, A3 there in these 2 options. Okay, yeah, so see this is a suitable answer we got from here, right? There is nothing to worry here, so third option is correct. I hope it is clear. Yes, last question of this session. So cyanides upon treating with the lithium aluminum hydride and followed by hydrolysis, so that will be resulting to form, see cyanide is there now, like this we should write. Okay, whenever we are taking lithium aluminum hydride, which is a strong reducing agent, it will converts into ammonia. So it will be converts into ammonia like this. So whenever we are treating with NaNO2 and HCl, that will be giving diazonium chloride, CH2 N2 plus Cl minus. Okay, so these upon treating with water hydrolysis, it will be giving us N2 goes out, so N2 gas will leaves from here, OH minus will be substituted in that place. So CH2OH, benzyl alcohol will be produced. So that is there in the option number 1. So that is the answer for this particular question. I hope the session is really helpful for your preparation. So whenever you are watching these sessions, so just pause the video and give a try from your side, then watch the answer. So that is how you need to practice, that is how you need to improve. So do not depend upon the directly only on the faculties. First you give a try, after that you can look into the answer from the faculties. That's how you can verify the answer. Okay, I hope it is really helpful, and if you really like the content, please click on the like button, also share with your friends. Okay, so if there is any difficult topic, write in the comment box, I will be looking for it and I will be covering it in the upcoming sessions. Thank you.